Okay, I'm going to go ahead and get started. Today we're going to do the last kind of factoring that we're going to talk about for this chapter in 6.5, and we're also going to cover 5.8, which is division of polynomials. So what I have done so far is I've written on the board the 5 different types of factoring that we have talked about in chapter 5. So all of these 5 different kinds are what you're going to be tested over. So the very first thing that we talked about was the greatest common factor, which is where you pulled what was in common with all the terms. You pulled it out, and then you put in parentheses what was left, and you found what was left by dividing each term by whatever it was that you pulled out. So that was that 6.1. Also in 6.1, we had some problems that had 4 terms, and there wasn't a greatest common factor between all of those 4 terms. So we put them in groups of 2. That's what we call the factoring by grouping. So when we put them in the groups of 2, and then we pulled the common factors out of each of the smaller groups. All right, in 6.2, we talked about, and I started calling these the good trinomials, right? The good trinomials are the trinomials that are just start off with an x squared. Okay, if they just start off with an x squared, okay, they're much easier to factor. Okay, so that was what I'm going to call the good trinomials, and I'm going to show you an example of each one of these here in just a minute. So the good trinomials, again, they're the ones that start off with just x squared, and in my factors, I can jump straight to x and x. Okay, the long trinomials are the ones that start off with your x squared, but in front of the x squared is a number like a 5 or a 6 in front of the x squareds. That is what we call the long trinomials. And then in 6.5, this was in 6.3 and 6.4. This section, both of those sections covered that same thing. Number 5 is what we're going to do today in 6.5 is factoring the difference of perfect squares. Okay, so I'm going to pause it for just a second and let you write. Okay, so now that you have those written down, I'm going to show you an example of each one of these different types, and then I'll end up with this one, which is what we're doing today. Okay, so the first one was greatest common factor. So let's see what I'm talking about when I say that we're going to factor out the greatest common factor. So say we have a trinomial like this. It's got 3 terms. And the very first thing you're always going to look for is what is in common between these 3 terms. So what is the biggest number, not just any number, but what is the biggest number that goes into 6, 18, and negative 12? So let's think about that. What are the numbers that go into 6? Let's see, 6 does. 6 will be the biggest number that goes into 6, right? So since 6 goes into 6, let's check and see if it goes into 18 and 12 also. Does 18 divide evenly by 6? Which it does. Does 12 divide evenly by 6? Which it also does. So I know that I can pull out a 6 because that's in common with all of the terms. I also notice that they all have x's, right? This one has x to the 3rd, this one has x squared, and this one has an x. So what you want to do is pull out as much as you can from each term. So when I'm looking at these 3 terms, I want to look for the smallest exponent, which is this x to the first. That's as much as you could pull out of that one, which means that's as much as what is in common with all of those. So all I can pull out is a 6x. Now, to find out what is left after I pull out the 6x, remember, you divide each one of these terms by what you just pulled out, which is that 6x. And let's see what is left. So here, I had a 6, but I pulled it out. You're dividing here, which means if I'm dividing, I'm going to subtract these exponents. And if you're just an x, your exponent is a 1. So let's see, 6 over 6 divides x to the third over x to the first. If I subtract those exponents, I'll be left with x squared plus 18 divided by 6 gives me 3. X squared divided by x leaves me with just an x, right? Because if I subtract my exponents, I just have 1 left. Bring down my minus. 12 divided by 6 is 2, and those x's will cancel. So that is what is pulling out the greatest common factor. Okay? Now, let's look at the two different kinds of trinomials. One of the trinomials I called the good trinomials. The other ones I called the long trinomials. Let's look at the difference in how you would work these. Let's look at the difference between these two trinomials. This first one I call a good trinomial, and I call it a good trinomial because it's just an x squared. There's not a number in front of the x squared like this one. So this one's going to be long method. This one's going to be short method. If it is just x squared, you just jump straight to your factors, and at the beginning of each factor is an x. So I've got x and x to get x squared. The next thing you're looking for are the numbers that go at the end of each of your parentheses. And those numbers have to do two things. They have to multiply to equal 15. So let's see, my options would be 15 times 1 or 5 times 3. Not only do they have to do this, multiply to equal 15, they also have to add to positive 8. So when you're looking at your pairs, which one of those adds to positive 8? The 5 and the 3 do. And they both need to be positive, right? A positive 5 and a positive 3 need to add to positive 8. Now, this long method, I can't start off with just x and x because I don't need it to equal x squared. I need it to equal 6x squared. So the reason there is another method is because you don't know what you're going to start off with, because to get 6x squared, there's multiple ways to do that. You can either multiply 6x times x, that would be 6x squared, or you could multiply 3x times 2x, because that also equals 6x squared. So you don't know which numbers to start with. So that's why we have this other method. And the way you start off is you multiply this outside number times that outside number. So you have a positive 6 times a positive 5, which is a positive 30. Then you're going to make this little chart. Now, when you get in this chart, you're going to say, now you don't care about the 5 anymore. You care about the 30. You want the 30 to do two things. You need to find the numbers that multiply to equal 30. Now, 30 has more ways to multiply to get it. So if you wanted to use your calculator to come up with that, remember we did this calculator method, you would go to your y equals button, clear out whatever's in there, put in whatever this number is, which is a positive 30. So you'll put in positive 30, then you'll hit divided by X. This button right here is your X button. Then you'll go down. You're going to type in the same exact thing, another 30 divided by X. But after you type in that, you're going to now hit your plus button, and then you're going to hit X again. So what I want to see is a table that's going to find the numbers that I'm looking for, which are the numbers that multiply to equal 30 and add to equal 17. So what you're going to do is hit this second button, and then come over here and hit your table button or the graph button. So what you have here are all the ways to multiply to get $30. So I need to find the pair that's going to add to 17. So what you're going to do is look over here in your very last column. You're looking for whatever number this is. So I'm looking for 17 over here in my last column. And when I find the 17, you look at the other two columns, which is 15 and 2. Those are the numbers that are going to do what you need them to do. They're going to multiply to equal 30, right? A positive 15 and a positive 2 multiplies to equal 30. They're also going to add to 17, which 15 and 2 does, adds to 17. So now what you're going to do is you're going to create two fractions. Whatever this is right here, just without the squared, is going to be the denominator of both of your fractions. Now what you want to do is reduce these fractions. And remember, you can do that. If you don't like to reduce on your own, you can do that in your calculator. To get back to your home screen, hit the second button and then the button right next to it to quit. That'll bring you back to your home screen. So if I'm reducing 15 over 6, that's what you type in, 15 divided by 6. Hit enter. If you get a decimal like that, that means you need to hit math. And then you're going to hit enter twice, because what you want to do is turn that decimal into a fraction. So hit the enter button 2 times. That'll tell you what that fraction reduces to. So this fraction will reduce to 5 over 2. Do the same thing with your 2, 6. If you enter 2 over 6, then hit your math enter button, it will tell you 1/3. Here's where your factors are going to come from. So let's see, what is in the bottom of this fraction? It'll be a 2x. And then up top, now, after you reduced it, include the sign, so plus 5. And then the other one, in the bottom is 3x. Up top, including the sign, is plus 1. Okay, I'll pause and let you look at that. Okay, this leads us into the last kind of factoring, which is what we're going to cover today, which is called the difference of perfect squares. Okay, difference of squares will have 2 terms. This is like number 1. So I've got 2 terms. It's kind of like the trinomials that we've been doing, except there's 2 terms, but it's like the middle term is just a 0s. Okay, so that just like the trinomials that we've been doing, to get s squared, you're still going to start off with s and s. These two terms are what are called perfect squares, which means they have factors that are exactly the same that you would multiply to get them. Like s and s is the same, right? And you can multiply that to get s squared. What number is the same that you can multiply to get 81? So if we're talking about that, we're thinking about what numbers multiply to get 81, and they're the same number, which would be 9 and 9. When you're factoring difference of squares, one's a plus and one's a minus. Okay, let's look at another one. Like number 2. Well, number 2, I've got c squared minus 400. So again, it's got two terms. They are both perfect squares. I may not necessarily know that, but let's look at how we can figure this out, even if we don't know if 400 has that situation where there's numbers that multiply to get it that are the same number. Now, I know c squared does. C and c. Go to your y equals just like you did factoring trinomials and clear it out. And put this number in, negative 400. So if you put a negative 400, again, put in divided by x. And again, negative 400 divided by x, and here's your x button, plus x. Hit second table. So what are you looking for in your third column? You're actually looking, remember what I told you is that in the middle of these two terms, there is another c. It's just a 0 c. So I am looking in my third column over here for what numbers would add to 0. So I'm trying to go down here until I get to the 0. There it is. And look what numbers give it to you. Negative 20 and positive 20. So that is what you have here. A minus 20 and a plus 20. They multiply to negative 400. And they also add to that middle term, which is just a 0. Okay, let's look at number 3. Number 3, we have w squared minus 15. So when we try to do this, we do w and w for w squared. But then what are we trying to find? We're trying to find those factors of negative 15 that add to, again, my middle term is actually a 0w. So how do you multiply to get 15? So it doesn't matter what I do. None of those numbers are the same, right? Which means when I add them together, I'm not going to get a 0. Which means there are no numbers that I can put here and here that are going to multiply to negative 15 and add to 0. Because 15 is not what you call a perfect square number. right? If you take the square root of 15, you're going to get a decimal. It's not, if you take the square root of like a number like 25, where it says what number times itself is 25, you would use 5 and 5, right? 5 times 5 is 25. Or the number 9, 3 times 3 is 9. So all of those numbers have factors that are the same. 15 is not a number like that, which means you just can't factor using those numbers. So that polynomial is prime. Okay, what about number 4? You have w squared plus 64. So again, if I'm going to factor this, I would start off with the w and w for w squared. Now, 64 is one of those numbers that has factors that are the same, right? 8 and 8. But here is the thing. I would need those 8s to cancel, which means I would need a positive 8 and a negative 8 to get, again, the 0w in the middle. But if I need a positive 8 and a negative 8, those aren't going to multiply to positive 64. They would multiply to negative 64. So here's the rule. If you do have perfect squares, like those both are, 64 is a perfect square, but there's a plus in the middle. Instead of a minus, it is automatically prime. There will be no numbers that are going to multiply to positive 64 that would cancel each other out. So that's why that one is prime. The difference is if it was this, w squared minus 64, that I can work. I would do WW. I would use the 8 and 8 for the 64 and put one positive and one negative, right? Because that multiplies what is 8 times negative 8. That gives you that negative 64. And positive 8 minus 8 does give you the 0w that you would need to cancel out. So this one would work, but the one that you have in your homework is prime because it's a plus in the middle right there. Okay, looking at number 5. 5 has something new. All right, look at these numbers. We have 245s squared minus 180. So remember, the very first method of factoring that we talked about was greatest common factor. So it doesn't matter what section we're in or what kind of factoring we're doing. That is actually what you look for first every single time, is something in common. So when I'm looking at these numbers, I see 245 and 180. I'm thinking they have something in common that I need to pull out. And second of all, neither one of those are perfect squares, how they're written like that anyway. So I'm going to show you a trick in your calculator. If you only have 2 numbers and you're trying to find the greatest common factor, you can actually do it in your calculator. So what you're going to do is hit your math button. Then you want to come over here to number. After that, you'll go down to number 9 where it says GCD. That's gonna be your greatest common factor. So hit enter. Now, what you're gonna do is you're gonna enter both of those numbers. Don't worry about the negative symbol. So enter 245, then hit this comma button. It's because you want to separate the two numbers with a comma. So I put in 245, then I'm gonna hit the comma button. I'm gonna put in my other number, which is 180. So 180. And after I put in the 180, I'll put the closed parentheses. Hit enter. There it is. That's the greatest common factor. That's the biggest number that will go into 245 and 180, which means I have to pull that out, right? If there's a greatest common factor, you've got to pull it out. So if I pull out a 5, put in parentheses what is left, which means I need to divide both of these by 5. So let's see, if I do the first one, 245 divided by 5 gives me 49. Bring down my s squared. Minus 180 divided by 5. So if I divide that by 5, it gives me 6. Oh, no, that gives me, gives me 36. Now I think to myself, well, 49 and 36, aren't those special kind of numbers that have factors that are the same? Like, what's the number that is the same that you multiply together to get 49? 7 times 7, which means it's a perfect square. What about 36? Does 36 have numbers that you multiply together that are the same? It also does. 6 times 6. And since there is a minus, since there is a minus in between it, this is a difference of perfect squares, just like what we've been doing today. So I'll bring down my 5. In my parentheses, what's the same thing that can go here and here? And if I multiply it together, it'll give me 49s squared. Let's see, I need a 7 and a 7 to get the 49. What do these 7s need on them to get s squared? They need s and s, right? 7s times 7s will give you 49s squared. What can you multiply? What did we say the number was that you multiplied together? That's the same number that gives you 36. 6 and 6. And your signs are 1 positive and 1 negative. Always different signs. It doesn't matter where the positive and negative go. You just have to have one of each of them. All right, number 6. Number 6 says we have 32x squared plus 18. So let's see. Do they have a greatest common factor? And if you wanted to use that method, anytime you only have 2 numbers, you can use that method in your calculator where you go to math, down to greatest, over to number first, and then down to greatest common factor, which is GCD. Type in the 2 numbers. What are my 2 numbers? 32 and 18. So you'll have 32, comma, 18, and and then close your parentheses and hit enter. Well, 2 is the biggest number that goes into both of those. And I can't pull out any x, right? Because this one doesn't have any x to pull out. So all I'm pulling out is a 2. I'll put in parentheses what is left, which means I need to divide these both by 2. 32 divided by 2 gives me 16x squared plus 18 divided by 2 is 9. So then I think to myself, oh, these numbers look like perfect squares, right? Because you can use 4 and 4 to get 16. You can use 3 and 3 to get 9. But what did we talk about earlier is this has to be a minus in order for it to be a difference of perfect squares. Now, I do not answer this as prime because I did do something. I did pull out a greatest common factor, which means that right there is my answer. That's just as far as I could take it. I could pull a greatest common factor out, and then I just couldn't go any. Okay, number 7. We have v to the 4th minus 289. So, just like v squared is a perfect squared and you use v and v to get v squared, so is v to the 4th. Because to get v to the 4th, I can also use same numbers, right? I can use v squared times v squared to get that v to the 4th. Now, what about the 289? I'm not sure about that. So remember, you can still go to your y equals. There's 2 ways to do it. You can either go to your y equals and type in negative 289 divided by x, and then again, negative 289 divided by x, and then remember, hit your plus x. So what am I going to be looking for in my last column? Once I hit second and hit this table button, over here in my last column, I'm looking for that 0, right? Because I need the 2 numbers to cancel each other out since there's not a middle term that they're supposed to add to. So look at this, negative 17 and positive 17, which means 289 is a perfect square. I can use negative 17 and positive 17 to get it. So let's see, what is this going to end up being? What did we say would get us v to the 4th? V squared and v squared will get us v to the 4th. And what did we just find in our calculator? We can use a plus 17 and a minus 17. That will multiply to negative 289 and also add to that middle term that you just can't see because there are 0 v's in the middle here. Okay, so that's why those numbers need to cancel out. They need to make a 0. Okay, let's look at number 8. R squared plus 4r plus 4. Okay, when we are talking about this, so now look, this should look a little different. We're back to a trinomial. It's got 3 terms instead of the 2. So this isn't going to be difference of squares. This actually should look very familiar to something that you've already done, which we did in 6.2. This is one of those good trinomials because it's just an r squared. How do you get r squared? R and r. Now remember, what do these numbers do? What are the numbers that you want to multiply to equal this? So multiply to equal 4, which is either 4 times 1 or 2 times 2. And I need to add the pair together to also equal positive 4. So which one of these pairs adds to 4? 2 and 2 does. Both positive. R plus 2, R plus 2. which is fine. MathLab is going to take this. I'm going to take this. This is a perfectly fine answer. The reason it is in this section instead of in the section where we did all these trinomials like this is because when your factors end up to be the same exact thing, you can actually type it in a different way. What is the same thing as saying r plus 2 times itself would be r plus 2 squared, right? That's what it means when you multiply something times itself, is you're squaring it. So MathLab will take this answer or this answer. Either one of them are perfectly fine. Okay, same thing. 3 terms, but it's a good one, right? Because it's just r squared. There's not a number other than 1 in front of that r squared. So once again, I can start off by r and r. That'll give me the r squared. What are you looking for? Ways to multiply to get 81 and add to negative 18. Again, if you want to use your calculator, you can always use your calculator by going to your y equals and clear it out. Typing in a positive 81. 81 divided by x. And then another 81 divided by, again, here's your x. And then type in a plus x. Then hit second table. Again, what are you looking for in your last column? You're looking for that middle number, which in this case is negative 18. Now, if you start getting a bunch of decimals like I am all over the place, what you can do to kind of just reset your calculator is go to this second button and then hit this table set, which is your window button, and say, okay, this says where you want your table to start. So just put a 0 right there. If you put a 0 there, and then go back to second table again, it takes away all those decimal kind of numbers, okay? You still have some, but not nearly as many. So what am I looking for over here in this column? I'm looking for that negative 18. So I need to go up into my negatives here. So I get to negative 18. There it is. Which means what numbers do you want to use? 2 negative 9s, right? Negative 9, negative 9. Both negative 9s there. So again, you can type it in r minus 9 2 times, or you can type in r minus 9 squared. Either way. Okay, x squared minus 5x plus 25. So let's see if this one works. Again, x and x for x squared. But then what are you looking for? You're looking for the numbers that multiply to give you 25. Now I could go to my calculator, that's fine, but I know the ways to multiply to get 25. There's not that many of them. 25 times 1 and 5 times 5. Now, are either one of these pairs going to add to this middle number, which is negative 5? Can you make 25 and 1 add to 5, or can you make 5 and 5 add to -5. You can't do that with either one of those pairs, so this one is also prime. Okay? Okay, I'm going to put this one up here, and then I'm going to pause it and let y'all try to work this. So the first thing you're going to do is look for something in common. Is there something that goes into 3, 36, and 108? If there is, pull it out, and then factor what is left. So I'm going to pause this and let you try to work that. Okay, so what did you see that you could pull out of here? What goes into all three of those? The number 3 does, right? They all divide by 3. So I'm going to divide them by 3 and see what's left. So if I divide this first term by 3, I pulled out the 3, so all I'm left with is that x squared plus 36 divided by 3 gives me 12x plus 108 divided by 3 gives me 36. And then let's see if we can factor what is in here. This 3 is part of your answer, so it does come down. Now, the good news is when we pulled out that 3, that made this be one of those good trinomials where it's just x squared. So x and x. So now what are you looking for? You're looking for numbers that multiply to give you 36. And at the same time, add to give you 12. So if I multiply to get 36 and add to 12, I will use 6 and 6, right? Multiplies to 36 and adds to 12. Okay, let's look at number 12. You got 3y to the third minus 24y squared plus 48y. So let's see, I do notice they all have a y. So I already know ahead of time that there is something in common with all of these terms. They all have a y. What else will go into all of these numbers? The number 3 will, right? 3 goes into 3. 24 divides evenly by 3, and so does 48. So I can divide them all by 3. So I'm going to pull out a 3 and a y. Put in parentheses what is left. So if I pulled the 3 out here, I pulled the y out, right? So we're dividing all of these by that 3y that we pulled out to see what's left. So if I pulled out the 3, I have y to the third over y to the first. So that leaves me with y squared minus 24 divided by 3 gives me 8. Y squared over y is y. Plus 48 divided by 3 gives me 16. And I pulled out the y. So now let's see if we can factor what's left in here. Sometimes you can, sometimes you can't. So this 3y will come down. And once again, when you have y, just a y squared here, that's the good kind because it's just y and y. So what are you trying to find? Factors of 16 that add to, be careful here, -8. So if you're worried about your signs, anytime you're worried about your signs, use the calculator method, which is always go into your y equals, so your y equals button, and then clear it all out. then you're typing in that last number. That last number is what you want to see in your y equals. So 16, and then hit divided by x, and then hit 16 divided by x plus x, and then go to second table. And remember, you're always looking for that middle number, which in this case is -8 in your last column. So here's my -8. So what does that mean I need to use? -4 and -4 are my numbers that will give me that -8 that I want. So that's why I use -4 and -4. Okay? All right, number 13, you have 4v squared plus 12vg plus 9g squared. All right, so this one's a little bit harder. First of all, like the last ones, I'm looking for something in common. I have a 4 and a 12. They have stuff in common, but when I put that 9 in, they don't all three have something in common, right? Because what goes into 4? 2 and 4 does, which those both go into 12, but neither one of them go into 9, which means I can't pull any number out. This one has V, this one has V, but this one doesn't. Now also, look, these both have G's, but this one doesn't. So there's nothing that all three terms have. So I have a trinomial and there is a number in front of V squared, which means this is the long method. Okay, remember the long method trinomial is when you multiply this number times that number. Sign and everything. So you have +4 times +9, which is +36. What are you looking for now? You're looking for numbers that multiply to equal +36. So this is the number that you would put in your y equals, is that +36. On the long method, once you multiply these outside numbers together, you don't care about that number anymore. You want to put this number in your calculator, in your y equals. So again, you're going to your y equals and you're putting in 36. So it should look like that. 36 divided by x and 36 divided by x plus x. Now, what number are you looking for in the middle? +12. So that is what you are looking for in second table. You're looking for 12 in your last column. So in your last column, now see my 12 down there at the bottom. So there's my 12, which means I want to use 6 and 6. So they're the same, multiplies to 36, adds to 12. You're going to put them both over 4v, right? This is the long method, like 6.3 and 6.4. Then you're going to reduce these. Let's see, if I put 6 divided by 4 in my calculator, and then hit math, enter, enter, it's going to give me 3 over 2. This is the same exact fraction, so it's going to give me the same thing, 3 over 2. Now, that's where my factors are going to come from. What's in the bottom of this fraction after you reduce it? 2v plus what's up top? Plus 3. This one's the same thing, right? 2v plus 3. Now, here's what's interesting about this one, is this number right here has to multiply to give you what's at the end here. So I see the 9. 3 times 3 is 9. But what do these 3's need on them to get 9g squared? Both of these 3's need g's on them, right? 3g times 3g is what will give you that 9g squared. Okay, then last one from this section. Actually, I'm gonna take that one off. I'm gonna take off number 14. So I'll take it off of your homework also. So you won't have a number 14 on your homework. It'll just go to number 13. Okay, so I'm gonna take that 14 off of your homework because we also need to do 5.8 today to finish this module. Okay, 5.8, so all of that was on factoring. What we're going to do in 5.8 is we're going to do division of polynomials. Okay, so let's think about this. On number 1, you have x squared minus 3x minus 18, and you're going to divide that by x minus 6. Okay, so we're going to do this by what's called the long division method. Hang on just a second. Okay, so when we're doing long division, remember long division looks like this. It has this little symbol like this. What is inside this symbol is what's on top here, because this says that what this numerator is divided by x minus 6. So the way we show that long division wise is we put x squared minus 3x minus 18, and then we divide that by x minus 6. Okay, so now the first step that we're going to do is we're going to look at two things. We're going to look at these two terms right here, this term and that term. So the x and the x squared. What we're going to say to ourselves is, what do I need to multiply x by to make it x squared? What do you multiply x by to turn it into x squared? X times x, right? So what you're going to do is you're going to put that up here. X times x will give you this x squared. Now what you're going to do with this x is you're going to multiply it times both of the terms out here and put your answers right here. So again, like we said, x times x gives you x squared. X times negative 6 gives you negative 6x. And then you're going to subtract this from the terms above it. So let's see here, we've got x squared minus x squared. That's why we did it. We want that to cancel. So that ends up being nothing. They cancel, right? X squared minus x squared. Now, remember this. So this is a negative 3x minus negative 6x. So what happens there? If you're subtracting a negative, that really says negative 3x. That turns that into plus 6x. So negative 3x plus 6x gives me positive 3x. Then you drop this down. And we're going to do this several times. So drop down the minus 18. Start all over. So now, again, now what you're looking at, again, you're looking at the first terms. You're looking at x and 3x. What do you need to multiply this x by to turn it into 3x? What do you multiply x by to make it 3x? X times positive 3 will be positive 3x, right? So that's what you put up here, is positive 3. And then you do that multiplication. I'm going to do this 3 times both of these. So what is 3 times x? 3x. 3 times -6 is -18. And look what you get when you subtract that, because that's what you always do, is subtract it. 3x minus 3x is nothing. -18, what does this turn this into? Minus -18. So that really says -18 plus 18, which is also nothing, which means since there's nothing left to bring down up here, this right here is your remainder, which just means you don't have a remainder, which means x plus 3 is your answer. We're going to do several more of these. Let me switch these blinds. I'm going to see if I can fix that glare, Darian. Oh, that's a little better. Okay, so again, what's inside here, or what's on top, we'll go what's inside your division symbol. So that'll be your 2x squared minus 6x minus 20. What's under here will come out here. So x minus 5. Start off the same way. So again, looking at this first term, which is x, and this first term, which is 2x squared. What you're trying to do is turn this term into that one so that when you subtract them, they're going to cancel. So how's that going to happen? X times what will give me the 2x squared. So let's see, I'll need an x time. First of all, I need a 2 to get the 2x. And what do I do to turn the x into x squared? I need an x. So 2x times x will be that 2x squared. Now let's multiply. 2x times x, there's my 2x squared that I want. 2x times -5 gives me -10x. And then remember, you're going to subtract all that. That's how these cancel right here. Because 2x squared minus 2x squared cancels. So then we move to the second terms. You have a -6x. What does this turn this into? Since it's minus negative, that turns that into plus 10x. So you have a -6x plus 10x, which is 4x. Bring down the minus 20. And then start again. What do you need to multiply x by to turn it into 4x? X times +4 will turn into 4x, and that's exactly what you're going to do. You're going to multiply this 4 times both of these. So 4 times x gives me 4x. 4 times -5 gives me -20. And then that's what you're going to subtract. And once again, look what happens. 4x minus 4x is nothing. This minus turns this right here into a plus. So you have -20 plus 20, which again is nothing. So you have no remainder. So this right here, that 2x plus 4 is your answer. Okay, and Darian, I know we're going to go a little bit over to get through this 5.8, but we need to get through it this week. All right, number 3. It's written different. You have x squared minus 15x plus 54. Divided by x minus 9. So again, if we're going to write this as long division, what's inside here will go inside your division symbol. Because you're doing this, x squared minus 15x plus 54, then you're going to divide it by x minus 9. What you're dividing by always comes out here. So you have x squared minus 15x plus 54 divided by x minus 9. So again, start with these two terms. X times what will turn into x squared? What do you need to multiply x by to make it x squared? Well, you need an x. Then do your multiplication. X times x gives me x squared. X times negative 9 gives me negative 9x. Then I'm going to subtract that. That's how I'll get my x squareds to go away, right? X squared minus x squared is nothing. Once again, this minus turns this negative into a positive. So you have negative 15 plus 9x. So negative 15x plus 9x is a negative 6x. Then drop down that positive 54. And then start all over. What do you need to multiply x by to turn it into negative 6x? Well, you need to multiply the x times negative 6. Negative 6 times x is negative 6x. Negative 6 times negative 9 is positive 54. And then subtract it. And then again, what happens here? What does this turn this into? A plus 6x, right? So you have negative 6x plus 6x, which is nothing. You've got 54. That turns that into a negative 54, which is also nothing. So there just is nothing left over. There's no remainder. And x minus 6 is your answer. Right, number 4. Okay. So I've got 8x cubed minus 20x squared minus 16x minus 2. And I'm going to divide it by 4x plus 2. So this is what goes inside. So 8x cubed minus 20x squared minus 16x minus 2. Oh, it's a long one. Then 4x plus 2 comes outside. So let's see, looking at our first terms, what do you need to turn 4x into? You need to turn it into 8x to the third. So how do you turn your 4 into an 8? You'll need to multiply it times 2. How are you going to turn x into x to the third this time? What do you need to multiply x by to make it x to the third? You would need to multiply it by x squared, right? Because x squared times x is what's going to give you that x to the third that you need. So let's see. 2 times 4 gives me 8. The x squared times x gives me x to the third. Then what do you have? Then you have, let's see, what do we need to do? 2x squared times positive 2. So 2x squared times positive 2 is positive 4x squared. Then you're going to subtract this. 8x cubed minus 8x cubed cancels. Now, what does this turn this into? It turns it into a minus, right? So you've got negative 20x squared, and you have minus 4x squared. So negative 20 minus 4 gives me negative 24x squared. Bring down just your next term, which is negative 16x. And start all over. What do you need to multiply 4x by to make it negative 24x squared? So 4 times what gives you negative 24? You need 4 times negative 6. X times x will give you that x squared. So you need negative 6x up there. You've got negative 6x times positive 4x, which gives me negative 24x squared. Then you have negative 6x times positive 2. Well, negative 6 times positive 2 gives me negative 12x. And again, we're going to subtract this. So let's see. That turns this into a plus. That's why the 24x squareds cancel each other out, right? Because you have negative 24x squared plus 24x squared. It also turns this into a plus, right? If I make this come here, it turns that into a plus. So I've got negative 16x plus 12x, which is negative 4x. Now what am I bringing down? I'm bringing down the next term, right? I've already brought down the negative 16x and used it. But now I need to bring down this negative 2. And start all over for the last time. What do you need to multiply 4x by to make it negative 4x? Well, it's almost exactly what I need it to be, isn't it? I just need to change its sign from positive 4x to negative 4x, which means I need to multiply it times a negative 1, right? Isn't that what'll change the sign? So let's see, negative 1 times 4x gives me negative 4x. Negative 1 times positive 2 gives me negative 2. And anytime these two things are exactly the same, when you subtract them, there's not going to be anything left, right? They're the same thing. So there's not a remainder, which means that right here is your answer. Okay, just a couple more. Okay, so this one has a couple of new things that we need to talk about. okay? When there are missing terms, like these have missing terms, because look, it jumps from x to the fourth to x squared. It's missing the x to the third term. You can't jump terms. You have to fill in the missing term. So anytime there is a missing term, I'm going to fill it in with a 0 for that term. Here and here, I noticed that this one has a missing term also. It jumps straight from x squared to the constant. It's missing its x. So I'll show you how you write that. You're going to fill in for your missing terms. So let's see. Inside here, it starts with x to the fourth. Since there's not an x to the third, I'm going to fill it in with a 0 x to the third. Then I can put my x squared, so plus 2x squared. Is there an x? Since there's not an x, I'll put a 0x, and then my minus 15. Hang on just a second, Darian. Okay, so I'm going to divide this by the x squared minus 3. And again, I've got to fill in those missing terms. So I'll have an x squared. Then since I don't have an x, I'm going to fill in a 0x and then the minus 3. Now, I'm going to start the same way. I'm going to look at these first terms. I've got an x squared here and an x to the fourth here. What do I need to multiply this x squared by to make it x to the fourth? I need to multiply x squared times x squared. Now let's do that multiplication and see what happens. X squared times x squared, there's my x to the fourth. X squared times 0x is 0x to the third. X squared times negative 3 gives me negative 3x squared. And then let's subtract this. So let's see, my x to the fourths cancel. My 0x to the thirds cancel. So I'm all the way down to here. So I've got this 2x squared. This minus turns this into plus 3x squared, right? So that's going to give me 5x squared. And then I can go ahead, since this is a 0, I can go ahead and drop all of this down. Plus 0x minus 15. And then start over. What do I need to multiply x squared by to make it 5x squared? I need to multiply x squared times 5. So I've got 5. I'm going to multiply it times all of this. So 5 times x squared is 5x squared. 5 times 0x is 0x. And 5 times negative 3 is negative 15. And then look, since they're exactly the same again, this, what's here and what's here are the same exact thing. That means if you subtract them, there's not going to be a remainder. So there is no remainder. So your answer is x squared plus 5. Okay, let's try number 5. Oh, that was number 5. Oh, good. We're on number 6. 2 more. You've got x to the fourth minus 25 divided by x squared plus 5. So again, we're going to set this up as long division. Filling in our missing terms. So let's see, if I start with x to the fourth, that means I'm going to need an x to the third, which I don't have any. So 0. I need an x squared and an x, right? I'm missing both of those. So I filled in zeros for the x cubes, x squareds, and x's, and then that minus 25 at the end. Out here, again, if I'm starting with x squared, I need to fill in a 0x and then the plus 5. So let's see. Here I've got x squared times what to give me x to the 4th? Well, x squared, I'm going to erase this so I don't get it all bunched up. X squared times x squared, right? I need x squared times x squared to get x to the 4th. X squared times 0x is 0x to the 3rd. X squared times 5 is 5x squared. So let's see what happens when I subtract this. My x to the 4ths cancel. My x to the 3rds cancel, right? Because they're both zeros. So what does this one turn into? I have 0x squared. This turns this into what x squared? Since it's positive and I distribute this minus, it turns it into negative 5x squared. So I've got 0 minus 5, which gives me minus 5x squared. Now I can drop down both of those and see what's left. What I need to multiply x squared by to turn it into negative 5x squared. I'll need x squared times negative 5. Negative 5 times x squared is negative 5x squared. Negative 5 times 0x is 0x. And negative 5 times this positive 5 is negative 25. So once again, look, aren't all of these terms the same? So since they're exactly the same, when you subtract them, you're not going to have a remainder, and there's your answer. All right, last one. Okay, this one's going to kind of be a picture geometry kind of problem. You've got this rectangle. And it says the width of the rectangle is 3x plus 2. And the area is 3x to the 3rd plus 5x squared minus 7x minus 6. So what it doesn't tell me, it tells me what the width is, and it doesn't tell me what the length is. It just tells me what the area is. So what do I know about area of a rectangle? The area is equal to the length times the width. So what I know is the area, which is all of this. So 3x to the 3rd plus 5x squared minus 7x minus 6. So there's my area. That's what I put in place of area is equal to, I don't know the length, times the width. I do know the width. What's your width? 3x plus 2. So it's asking you to find the length, which means it wants this by itself. So what do I need to do? Since this is length times width, and here's my width, to get rid of this 3x plus 2 so that length will be by itself, I need to divide by 3x plus 2. If I do it on that side, I've got to do it on this side. So it'll cancel it here. That's going to be my length, which will be my answer. So what is the problem asking me to do? It's asking me to divide 3x to the 3rd plus 5x squared minus 7x minus 6 divided by 3x plus 2. So I'm going to erase this and write that out. So let's see, I had 3x to the 3rd plus 5x squared minus 7x minus 6. And I'm going to divide that by 3x plus 2. Okay, so we're going to divide this one just like we've been doing the other ones. And what we have left up here will end up being the length of that rectangle. So what do you need to multiply this 3x by to be 3x to the third? Well, I've already got the 3, so I just need to turn this x into x to the third, which means I need to multiply it by x squared, right? Because x times x squared will get me x to the third. So now let's do the multiplication. X squared times 3x will give me 3x to the third. X squared times 2 will give me what? What's x squared times 2? Well, it's 2x squared. And then I'll subtract. And let's see what is left. My 3x to the thirds cancel. This turns this one, right? So if I distribute this minus right here, that says 5 minus 2, which gives me positive 3x squared. Drop down your next term, which is the negative 7x. Let's keep going. What do you need to multiply 3x by to make it 3x squared? Well, I've already got the 3, so I just need to turn the x into x squared. So I'm going to make it x. So x times 3x is 3x squared. X times 2 is 2x. And then I'll subtract that. So here again, my 3x squareds cancel. I've got a negative 7x. And what does this minus turn this 2x into? Again, it changes the sign. So it turns it into a negative 2x. So I've got a negative 7x minus 2x, which is negative 9x. And drop down the last term, which is minus 6. And start all over for the last part. So let's see. I've got 3 times 3x times what to get negative 9x? I need 3 times negative 3 to make it negative 9, right? So negative 3 times positive 3x gives me negative 9x. Negative 3 times positive 2 gives me negative 6. And then when you subtract that, once again, look, these are the same and these are the same. So what does that mean you're going to get when you subtract? Nothing, which means there is no remainder, which means here is your length, which is your answer. Okay, so you've got quite a bit of assignments due this Sunday. You've got 6-3, 6-2, 6-3, 6-4. No, wait, 6-3, 6-4, 6-5, and 5-8. So 4 sections that are due this Sunday.